Everyone, welcome back to our channel. Now we are going to discuss about very short answer questions in dual nature of radiation and matter. So this is compulsory, one question is compulsory coming in board exam. In this first very short answer question is, what are the cathode rays? What are the cathode rays? Cathode rays are nothing but electrons. Normally we can't provide the electrons. Suppose this is atmosphere. Atmosphere is having many gases. At normal temperatures, pressures, all gases are acting like a bad conductors, means these are not discharging the electrons. Suppose we are taking the gas inside the vacuum chamber and we are taking the two terminals, one is the cathode, another one is the anode. Here we can fill the gas. And inside the tube, we are providing the low pressures and high potentials, 0.01001 millimeters of Hg, and potential is the 15 kilovolts to 20 kilovolts. Then these gases are discharging the electrons. These electrons are liberating from this one, and these are called the cathode rays. So simply we should remember that cathode rays are nothing but electrons at high potential and low pressures are gases are discharging the electrons. Then our second very short answer question is, what is the importance of Millikan's experiment? What he established. Suppose I am asking one question to you. What is the charge of the electron? We can say charge of the electron is 1.6 into 10 to the power of minus 19 coulombs. Who discovered this one? From the Millikan's oil drop experiment, he discovered that charge of the electron is 1.6 into 10 to the power of minus 19 coulombs. And you know what is the quantization of the charge? Any charge, any body charge, we can calculate plus or minus N. N is the number of electrons and E is the charge of the electron. Then our third very short answer question in this chapter is, what is the work function? What is the work function? Work function is coming from photoelectric effect. Here also we are taking one tube, one provision of window is there, two devices we are taking. This is the emitter and this is the collector. When this plate is illuminated by the electromagnetic radiation, then electrons are liberated from this. This is called what? Photoelectric effect. This is called the photoelectric effect. So when the electromagnetic waves, nothing but light rays are falls on the surface, electrons are liberated from that. That is called what? Photoelectric effect. In photoelectric effect, we are getting the work function. See, the minimum energy required to liberate the electrons from the emitter is called what? Work function. So we require some suitable frequency to liberate these electrons from the emitter. So we can give that the minimum energy required to liberate the electrons from the metal surface is called what? Work function. Then our fourth very short answer question is, what is photoelectric effect? Just now I said, what is photoelectric effect? When the surface is illuminated by electromagnetic radiation, then the electrons are liberated from the surface. This is called the photoelectric effect, and these electrons are called the photoelectrons. Okay, nowadays we are suffering from the global warming, and everyone, we should focus on electrical vehicles and solar energy. Mostly we are using the solar energy. The base is coming from this photoelectric effect. So based on this, without pollution, without damage of anything, we can produce the electricity from the photoelectric effect. Then our fifth very short answer question is, give the examples of photosensitive substances. Just now I said, when the light is illuminated by the surface, when the light falls on the surface, electrons are liberated from that. But which materials are suitable for this? Alkali metals like sodium, potassium, lithium, cesium. These are photosensitive metals. When light falls on this, immediately electrons are liberating from this. So instead of all type of materials, we can choose the alkali metals. Then easily we should conduct the photoelectric effect. So these are the alkali metals like sodium, potassium, lithium are the photosensitive metals. Then our sixth very short answer question is, write down the Einstein's photoelectric equation. See, Einstein discovered this one and he given one expression. Look, when the light falls on the surface, light is coming like a small energy packets. These are called the quantas, and later we are calling these are the photons. So when the light falls on the surface, it is utilized into two ways. A part of energy is utilized to liberate the electrons, that is nothing but work function, we know that, and remaining part is utilized to move the electrons from emitter to collector with maximum kinetic energy. So we can write it that energy, first part is to liberate the electrons phi naught plus, remaining part is giving to electrons, we can write it, this is the maximum kinetic energy. But energy we should write it is photons h nu phi naught plus Ke maximum. From this we write it Ke maximum equals to h nu minus phi naught. H nu minus phi naught. This is seventh very short answer question is, write the expression for de Broglie wavelength. He given the relation between wavelength and momentum of the particle, lambda equals to h by p. H is the Planck's constant, p is the momentum, and lambda is the wavelength of the particle. Then our last very short answer question is, write what is the statement of that Heisenberg's uncertainty principle. According to that, it is impossible to measure the position and momentum of the particle at the same time. So change in momentum and change in position is always greater than or equals to h by 4 pi. This is called the Heisenberg's uncertainty principle. Just we can say that at the same time it is impossible to measure the position and momentum of the particle. Thank you everyone.